So welcome back, and let's continue working with our R factor with climate research unit precipitation data. So when we already reprojected our monthly precipitation to UTM format and added also our precipitation annual for 2020 UTM format, also not this precipitation which we extracted for our study area, but general precipitation for our study frame, study extent. We should now calculate our factor for each month and then sum it to annual R factor using this formula. So see, so it's power 10. So for each month we should calculate square of the month divided to annual precipitation. That's why we need this file. Logarithm 10 multiplied 1.5 minus this 0.08, and this is all power of 10, which is multiplied to 1.735, and this is for 1 month. And afterwards we will sum all months together, and we will get our annual precipitation for our study area. So for this we'll start working with model builder. Let's click to model builder and just drag all the reprojected monthly data, band reprojected monthly data. So where is 14? It's 14, 15, 16. So for all months it will be large model builder. 17, 18, 19, and last one for December. Just a minute. So I added all my let's just make it bigger, my all monthly data, and we will work with raster calculator. Let's open ArcToolbox, and in map algebra, spatial analysis tools, map algebra, just drag raster calculator, and let's copy it to for all our months. Just Ctrl C and Ctrl V. So I arranged my raster calculator with output files, and let's start from the initial one, the first month. So we should type this formula to each raster calculator, and we will at the final point step we will use cell statistics sum. So let's start 1.735 multiplied to, so, and here starts 10 power. This is power. So for this we will use power function. It's here, power, just drag it, power and 10, and here we will write this side 1.5 multiplied and then logarithm 10 logarithm 10, and inside, so this is a square of monthly precipitation, in this case for January, divided into annual precipitation. So monthly precipitation, so this here we can just click and double click, multiply it again to this and divide it into our annual precipitation. Where is it? Yes, this one. Just drag, divide it into annual precipitation. So logarithm 1.5 multiplied logarithm, and the last point is minus this, minus 0.081, right? 88, and this will be for, so let's create new folder and just R for months, right? Months, and this will be R for January. So see, it's automatically added this annual precipitation, and you can see here double lines, double vectors, because we squared this. So let's copy this function and copy and paste, but we should substitute here this part to 10, band 10, so it's February, multiply 10, and again we will choose R for February. So it's automatically added this one, and the next part is calculate. So again we should repeat the same steps, just open, paste, should delete this part, and double click to 11, double click to 11, and this is R for, oh no, I should change the location, R for March, right? Okay, and so I will pause the video here, just repeat the same steps for each raster calculator, and add connected with a separate band, and do not forget to write correct output name, so it really will facilitate your work. So I will pause I am pausing the video here. So I finished connecting my raster calculator with my bands. So each month is ready now: January, February, March, April, May, June, July, August, September, October, November, December. So 12 months are ready. So it looks like this. See, annual precipitation connected with each raster calculator, and so it looks very messy. So, and the last step is to use local cell statistics. So I open it, and I should sum my all these R factors, which I'm going to calculate using raster calculator. So I'm adding my R factors, presumably already assessed: September, November, December, and here's one is October. So 12 months are ready. So I will choose here sum, and this here I will choose R 2020. Let's click OK. I hope, see, it's automatically connected with outputs. So at first I will go to validate. I hope everything is okay. And by the way, do not forget to save your model. So I will this one, R-3. So, and now I can run my model. So it's running. So far so good. So it's completed now, R2020, and I should just see my result. R2020, I'm going to my layers and months, R2020. So this is my final R factor. I can just, where is my, yes, this is my R factors. We can see that area of R factor varies for the whole study area from 124 to 865, but for my study area it should be a little bit smaller, so I will extract it first, extract by mask, and I will use this R2020, and where is my study area? Don't forget to choose R for study area 2020. Okay, so it's extracting. They all have the same projected coordinate system, UTM, so that's why it's easy to work. I think it's already extracted. No, oh, it's done, it's already doing. So I can close this part. By the way, I forgot to at first, let's R2020, let's change the cell size to 30 to 30 meters, because it makes mistake during the extraction. So my R for, no, this I can leave the same, do not change this one. Okay, let's at first extract. I'll pause the video here. So I extracted, I exported my R2020 to 30 pixel resolution. See, don't look to this, because it's actually not the pixel resolution, it's the values which has the same close pixel resolutions. So, and now we should extract our study area here using again extract by mask. This we need R30 and precipitation study area. I can change it to our study area 30 meters. Okay, let's click OK. See, we can check even it's extracted, so we can check actually. So it's 30 to 30 meters, and this number of pixels and columns and rows, whereas here we can see that this cell size and this number of columns and rows. So I will close these values, and this is my final R factor for my study area, with a pixel resolution of 30 to 30 meters grid, and with the sufficient UTM zone. So we calculated R factor using climate research unit, and in the following video we will use the data which we ordered through European Commission Joint Research Unit, and we just will extract the certain area for our study area and compare with this which we calculated. Hey guys, if you liked the video, please consider supporting the channel by purchasing online courses via my Udemy's profile, GIS Lab. Here you can find multiple courses regarding GIS remote sensing. The link to the profile is below.